Hello and happy Friday, eighth grade. Yes, okay, I know. Let me address it right now. Same shirt I've worn in every single video this week. Okay. Again, no, it's not just I'm being a slob and I'm just wearing the same thing every day. Okay. I'm not. The actual reality is I filmed all three videos this week on exactly the same day. In fact, it is Tuesday, April 7th. And you can even look, I don't know if it should be in front of it. It's actually 4:34 in the morning on Tuesday, April 7th. I actually get up early in the morning when it's quiet around my house and film these then. So I'm filming all yours in one day. Tomorrow I'll do it for one of my other classes and I'll be wearing a different shirt for them and so forth. And then just to show you, I go to Google Classroom and this is what you're doing right now. I mean, well, I'm speaking right now. This is Tuesday, April 7th. This is what we're doing. And what I'm doing is posting these for next week in advance. So you won't be seeing this video until April 16th or actually April 17th because it's 11:45 p.m. when it goes live. But I'm filming it, 10 days in advance just to get ahead and to keep track. So we've been talking about probability. What we've mostly been talking about is what's called theoretical probability. For example, when you talk about flipping a coin, when you talk about, say, flipping a coin 10 times, you say, based on probability, how many heads should you get? Well, if you do 10 times, you should get 5 heads, 5 tails. Does that mean you're going to get 5 heads and 5 tails? Not necessarily. You could. You could also get 6 and 4, 7 and 3. You could even get 10 and none. It is actually possible. And later on this unit, we'll talk about what's called compound probability. To flip a coin 10 times and get 10 heads. A fair coin. I'm not even talking a two-headed coin. A fair coin 10 times and get 2 heads. Very unlikely, but it's possible. But that's just based on theory. Today we're going to look at probability. It's called experimental. That is based on an experiment or based on evidence of what is the likelihood. For example, if you think about going to a fast food restaurant, okay, say you're going to drive through to McDonald's, a Burger King, Wendy's, whatever. Say they have like a regular hamburger. Say they have a cheeseburger. Say they have a McWhopper. I know a McWhopper is actually I'm mixing two different ones, whatever. Okay, and say they have a chicken burger. Why would you go to a McDonald's or Wendy's for a chicken burger? I don't know, but I hear Popeyes was big, but I never checked theirs. So you might say, okay, what's the probability of going there and getting one of these? Well, you might say 1/4. There's 4 different choices, and probably getting hamburger might be 1 out of 4. Well, does that mean if you own this restaurant, you should prepare to make an equal number of those? Not necessarily. You may find out that out of your first 100 customers, that maybe 70 people got the McWhopper. Maybe 20 people got the cheeseburger, 7 people got the hamburger, and maybe 3 people got the chicken. So based on this 100, what are you going to prepare for? Well, you're going to prepare for selling a lot of McWhoppers and not a lot of chicken. So that's based on the experiment. The experiment says only 3 out of 100 people is going to want a chicken sandwich. Now, as you are open longer and as you sell more, you're going to get better data. Okay? But that's what experimental probability is. Experimental probability is a likelihood based on the evidence that you have. It's not theoretical in that, 4 sandwiches, 1 out of 4. It's based on the actual evidence. Okay, so let's look at some examples. And first one is a florist sold 12 bouquets yesterday, including 3 that were iris. Okay, what is the experimental probability that the next bouquet will be an iris? Well, based on the probability, there were 3 iris out of 12. Now here I'm happy about this because I want your answer simplified. So if you answered 3 out of 12 for 3/12, that is going to be wrong. Based on this experiment, the likelihood of somebody wanting an iris is going to be 1 out of 4. Okay? Okay, so it should be a probability of 1/4. There we go. Brenner surveyed 18 students at her school, found that 9 of them plan to take ceramics as their next elective. What is the probability students going to take ceramics? Well, it's 9 out of 18. And if you think of that as a fraction, it's simply 1/2. So there's roughly a 50% chance that somebody's going to want to take ceramics. As a fraction, that's 1/2. Okay, so let's jump up to the next level. Okay, so now we got a table of values. And it says restaurants often slip takeout menus under Debbie's apartment door. She counted how many menus for each type of restaurant. So this is probably not a common occurrence where you live. Probably a common occurrence in like New York City where there are big apartment buildings. And one of the ways restaurants will add is, yeah, they'll go from door to door and they'll just leave takeout menus. Okay. Where we live, we probably get those in the mail. In fact, I know we get them in the mail quite a bit. So it says, what is the probability that the next menu slipped under Debbie's door will be a Mediterranean West restaurant? I almost said restaurant. Well, in fact, I did say restaurant. Okay, that wascally rabbit. Well, there are 2 Mediterranean that she's gotten. Out of how many? Well, now we need to actually do a little arithmetic here. We need to add these all up. Let's see, 4 plus 9 is 13. Plus 2 is 15. Plus 1 is 16. Plus 2 is 18. She's received a total of 18 menus. And out of those 18 menus, 2 out of the 18 were from a Mediterranean restaurant. So I would say the experimental probability tells me that the likelihood that the next one she gets is from a Mediterranean restaurant is a 1 out of 9 probability. Okay. And I got that correct. Ning surveyed 20 students, found that 2 plan to take orchestra. What is the experimental probability that a randomly selected student takes orchestra? So I'm going to just type in 2 out of 20, which I know is wrong. But I'm going to take a moment to say, okay, there's the correct answer. There's my answer. And I realize, okay, I didn't reduce. So I'm not going to make that same mistake again. Again, I really strongly encourage you, if you may get something wrong, check it. Work smarter, not harder. You do this, up and down, up and down, up and down, IXL, you're going to end up working longer and doing more problems. Take a moment, figure out when you get something wrong. You're going to learn from that mistake, and you're not going to make that mistake again. All right. So jumping to the next level, there's all. Okay. And next level might be just simply higher numbers. Porter's a professional DJ. He looked back at the events he worked in the last quarter. He did 3 retirement parties, 8 Sweet 16 parties, and 31 bar mitzvahs. What's the probability his next event's going to be a retirement party? Well, he did 3 retirement parties out of, let's see, 8 plus 3 is 11. 11 plus 31 is 42. He did 3 retirement parties out of 42. That can be reduced because I know 4 plus 2 is 6. So 3 goes into 6, 3 goes into 42. So divide 3 by 3. I get 1. Divide 42 by 3. I get 14. So based on what he did last quarter, the probability that his next event's going to be a retirement party is 1 out of 14. Not very likely. In fact, it seems very likely that his next event's going to be a bar mitzvah. Okay. Submit it. Yeah. Garden store sold 72 packets, 9 with tomato seeds. Was a probability the next one be tomato seeds? 9 out of 72 and reduce. Yeah, that's also. Let's even jump to the highest level they have. Is this the highest level they have? Yep. Challenge zone. Ooh. Sandra is bird watching at the coast. That's a nice socially distant activity you can do. Because there's no rule about getting, around a bunch of birds. Okay? It's being around a bunch of strangers. Okay? Or even people who you know that may or may not have the virus. So, bird watching, nice socially distant activity. So, what is the probability the next one will be a cormorant? Well, let's see, 10 plus 20. She saw a total of 32 birds and 10 cormorants out of 32. And divide each of those 2, it's 5 out of 16. So probability it's going to be the cormorant is 5/16. And last one, we'll do the last one here. Of the 325 people who have taken their seats in the seminar, 75 have red hair. What is the probability the person next to you is going to have red hair? Well, you know what? I'll do it with red ink. It's 75 out of 325. And I'm noticing right now both of those numbers end with a number 75 or 25. So I'm going to divide each of these by 25. That's 3 over, 4, 8, 12, 13. There were 13. How did I do that so quick? Well, there are 4 25s in 100. So in 100, there's 4 25s. In 200, there's 8 25s. In 300, there are 12 25s. Because each 100 has 4 25s. So in 300, there's 12 25s. 325 has one more 25, so it's 3 out of 13. I hope you're impressed. You should be. Okay. Wrong button there. And it's awesome. I know, it's awesome. I hope you've enjoyed probability. We're going to certainly talk more about probability in the next couple of weeks, then move into a little bit of statistics. But that's it for today. Again, this should be one you should be able to handle fairly well. If you do have any questions, please don't hesitate to email me. Have a good weekend, and I will see you next week, which I'm probably going to be filming last week, but that's okay. Time's a little wibbly wobbly that way.